session. Okay, so as I said, I'm Daniel. I'm the Technical Customer Success Manager here at WinDriver. We've probably talked before. This is my email. Thanks for joining. We're going to have an introduction and a live demo of WinDriver, its functionalities, and how it works. So let's start with mentioning the fact that this is the first webinar among a series of 4 webinars. This is let's say, the most basic one, an introduction webinar. Next, we will have a PCIe automated skeletal code, like the PCI Diag. It's a diagnostic app, allowing to access the device instantly and perform operations. We will have a dedicated webinar for this feature or functionality. It's basically a user app, an automated user app, where you can perform operations on your device. This will take place next week, next Wednesday. If you want, we will publish it on our newsletter and our LinkedIn page. If you wish to get a link, contact me and I will send it to you. The next webinar we will have is a debugging methodologies webinar for drivers, including WinDriver's unique tools, but not only. This webinar can provide a lot of value and insights for kernel and hardware developers in general. So I really recommend you to join. We have a recorded session of this webinar also on our website. And the last one, which is, I know, a very highly anticipated and a very desirable subject, is the DMA webinar. In this webinar, we will cover DMA, what is DMA, and we will have a live demo of DMA and specifically how easy it is to perform a direct memory access with WinDriver, if it's with the samples or with the code you generate with the wizard. So I really recommend joining to each one of them. You can get links from our LinkedIn page or our newsletter. I'm sending emails, and you can contact me and I will send you a registration link. So you can join us. So what are we going to cover today? Today we will have an overview, as I said. We are going to discuss and show WinDriver's mechanism, how it works for both Windows and Linux. We are going to talk about WinDriver's kernel module, which is a very important part when talking about WinDriver's operation. We will cover WinDriver's main functionalities, if it's reading and writing to the device, interrupt handling, DMA, the CMake files, the kernel plugins, and the new addition, the predefined action feature from our latest version, WinDriver 16.2.0. Then we will have a live overview. Okay, we will open the wizard, create a project. We will be able to see a device, perform operations, generate a skeletal code. We will generate a code on Python and in C to demonstrate how easy it is. It's even easier with Python because you don't have to compile anything. And then we will talk about WinDriver utilities, which I will probably mention along the way. And we will talk about licenses and different types of APIs, which a lot of customers, a lot of users are not even aware of. So it would be interesting. Let's start. So what is WinDriver? I'm sure most of you are familiar with the concept of WinDriver. It's a driver development toolkit. Everything is taking place in the user mode. You probably know that there are 2 modes, main modes on our computer, the user mode and the kernel mode. the operations, the communication with the hardware is taking place from the kernel mode. It is a much more sensitive layer. If something breaks in the kernel mode, you will get a BSOD, and it is much more complicated to develop and to debug in the kernel mode. So what WinDriver offers is developing drivers from the user mode, and I will explain how in the next slide. But it makes the whole development process much easier. You will be able to call functions from the user mode to the kernel mode, and the potential for messing things up and break things decreases. WinDriver is cross-platform, meaning it works on Windows, Linux, and Mac OS. This is a great functionality because some drivers are meant to operate, are destined to operate in several platforms, so you can develop a cross-platform driver. And also the API that WinDriver uses has almost the same names on Windows and Linux. So if you need to develop drivers for both platforms, for multiple OSs, it would be easier to be familiar with the code and the functions and what everything does, and you don't need to made up a new methodology and new names for functions when working on drivers for other platforms. So as I said, we have different languages, C, C++, Python, .NET, PowerShell. You can generate driver code in different languages. I don't know if you saw that, but something like 2 weeks or 3 weeks ago, the American administration said, sent a message that C and C++ are not safe for development, and they encourage developers to use other languages. They didn't say which languages, and we all know that C is a very popular language when developing hardware and drivers. So you can generate code with different languages. So if you're concerned about the security or the future of C when talking about driver development, WinDriver already provides a solution for it. WinDriver supports any USB or PCIe device, regardless of manufacturer. Meaning, and we will see it soon, you can choose it from a list of the connected devices, and you will be able to work with it. It is not limited for particular manufacturers. What we do have is enhanced support for specific chipsets from Altera, Xilinx, and Lattice. And what does that mean? So we tested and developed samples for specific devices from Altera, Xilinx, and Lattice. Let's say for DMA purposes. That means that you have a template, and it may not be suitable for your particular device, but you have more, let's say, more inspiration, more help, more dedicated sample to work with, and we will see how you access it later on. So how does WinDriver work? As I said, WinDriver has an API from the user mode that communicates with the kernel mode. This allows the operation from the user mode. You have your driver, and driver is, I know, a very general. What we mean by that is your user app or your logic, okay? This is your code. So you bring the hardware, your FPGA or your card, your configured card. and you have a user app eventually where you can perform the operations. So when using WinDriver's API from the user mode, it is calling functions from the kernel module. WinDriver's kernel module, it is called WinDR VR, and the WinDR VR and the version. And this allows the access to the kernel mode. I will talk about INFs soon. It is more relevant to Windows, or only for Windows. But basically, you have a high-level API, which take place or can be operated from the user mode, and low-level API, which we not recommend to work with from the communicating with the kernel model in the kernel mode. Okay, so the high-level API starts with WDC, WDU, or WDS, and the kernel module, the API starts with do, okay, or other names of functions which are not WDC, WDU, or WDS to perform kernel operations. And we will see how to debug it also, and how the documentation can help in this case. Let's talk about INFs, really in short, because it is not relevant for both Linux and Windows, only for Windows. INFs are Windows way, it's Windows way to ensure and verify the access to the kernel part, to the kernel mode, to the hardware. It includes information. INF stands for information about the driver, where it comes from, who developed it, what access does it need. WinDriver comes with its own INFs, and you can generate your own INF with WinDriver. The thing is that your driver needs to be signed in order for it to gain access. It is not enough to have an INF, but you have to sign it. We have a solution for that. It's called the test sign mode on Windows. We had a dedicated webinar only for this feature. If you're interested, I can send you a link. Send me an email and I will send you a link about how to avoid this digital signature enforcement. So you will be able to install unsigned INFs on your development computer. If you want to distribute your driver, you would have to sign the INF, because you don't want to put your clients and users' computers at risk, and turn it on test mode just to run your driver. Okay, so we talked about the kernel module. What is really important to know is that it supports multiple programs at the same time. Okay, so with WinDriver kernel module, you can communicate with different devices and different programs from the user mode. So it's versatile, and you can run or communicate with several devices from the same kernel module if you have a more complex system. So let's go over the top functionalities, and we will see also everything on the wizard itself, on the live demo. What reading and write to the device is something that you all know. It is a very common action on a basic operation. What I want you to take from this slide is the fact that you can perform operations on different phases. And what does that mean? So the first access we have for the device is from the wizard, okay? You can create access registers and read and write to the memory from the wizard itself, and perform operations from the wizard. Actually see the data that is being written, or you can raise interrupts. We will see everything, but it doesn't end just there, because you have functions. As I said, WDC functions are high-level API, which we do recommend to utilize. You can perform operations, reading and writing operations from the code that is being generated. You can modify the code and make it there. And if you don't want, or you want to write and read after compiling the user app, you can do it from the user app itself. Okay, in this case it's USB. You can read from pipe, write to pipe, listen to pipe, and the same goes with PCI. You will be able to read and write to your device from each stage of the development. It helps for troubleshootings, for testing. It makes the development process much easier when it's that versatile. Let's talk about interrupt handling. So this is a very common, let's say, a request by clients. They raise interrupt in their device if their device supports it, and they want an interrupt handler that knows to listen to the interrupts and to add transfer commands. So this can be done here. Okay, we have the WDC int enable function. You can see on our documentation, there's a full chapter dedicated for interrupt handling. And WinDriver comes with an interrupt handler. It won't raise the interrupt. This needs to be done with your code, your device, but it will listen to interrupts. And you can add transfer commands and remove them once the interrupt has been raised. So you have, let's say, a built-in interrupt handler with WinDriver, which makes, again, spares you the time to develop your own interrupt handler, which can be quite exhausting. This is an example of how you see that an interrupt was raised. Got interrupt number 1. It gives the interrupt type and the message data for the interrupt. So you're not only accessing the device, but you can see the all operations that are taking place when you're using it. DMA is one of the more, let's say, complex operations you can do with the PCI device. It is also a very there's a high demand for DMA in order to improve the performance of the card. So we have a few tools that can help developers in order to utilize DMA. The first one is the DMA samples, and I will go over them afterwards. We won't dive too deep into DMA right now, but we will have a webinar next month, as I said, diving into DMA, including a live demo. So we have DMA samples with DMA functions, and everything is highly documented. So you can generate a sample code for DMA and see how it works, see the functionality, and also get inspired. So maybe it won't work on your device, let's say plug and play, but after you will edit, let's say the memory segments, if you will need to edit, let's say the VidPid, update your device's properties according to your device IP to this DMA sample, it should work, okay? And we have a lot of clients that utilizes these samples, and after modifying them correctly to correspond with their device, it worked. So we have the DMA samples and the DMA code, skeletal code, which I will show how to generate in the demo. How does it look from the user app? So it looks like that, choosing the DMA completion method, the DMA direction, and in this case, we wanted to send 30 packets of transfers to to offset 100, and this is the transfer itself. Okay, and then we got the flag that the DMA transfer completed successfully. So if you want to perform DMA via the user app, you can do that. We have the DMA XDMA GUI also, but it really works only on specific devices. We will go over the DMA code and how to do how to generate it later on the demo. CMake file is one of my favorite features. What is a CMake? CMake, it's a cross-platform build tool. Okay, you can generate a platform-specific build file for Windows, Linux, and Mac OS. It is basically a text file. Okay, but it includes all the definitions you need in order to build on different platforms. Okay, so you can see if it's ARM, 64, if it's Windows 32, and this is generated automatically. So if you know you will need to build for some reason, build your driver on cross-platform, CMake is your tool. It makes the building process much easier. We are recommending using it regardless of cross-platform or not, simply because it works. It is a very elegant build solution, and it is easy. So the CMake file can be generated on the wizard. I will show you exactly how, but this is a great tool. If you're not familiar with it, I really recommend utilizing it and exploring it. So another thing WinDriver offers is kernel plugin. If you are not familiar with kernel plugin, what it is, so kernel plugin is a chunk of code, okay, that is moved to the kernel mode. We said that there are user mode and kernel mode. Every time the kernel mode, there is a communication between the kernel mode and the user mode. There is a context switch. The context switch takes resources and time. So if you want to improve your driver's performance, you can create a kernel plugin and just move chunks of codes and operations from the user mode to the kernel mode. Let's say it may be more advanced options and capability in terms of ease of use, but it does improve the performance, okay? Because you're moving critical parts of the communications to the kernel mode, and you can generate kernel plugins from the wizard, and I will show you exactly where. When talking about debugging, so we have the debugger, and I will show you how it goes. It monitors also kernel plugins, so no additional debugging is required because you have WinDriver's WD debug tool. We will see it. The last feature I will talk about, and there are a few more that I will not talk about before the demo, is the predefined actions features. We have a dedicated webinar only for predefined actions. Predefined actions is a new feature that was added to WinDriver 16.2.0. Basically, it's a no-code creation of predefined action flows. What does that mean? It means that you set the flow. Let's say you want to write to a specific memory segment, and then you want to read from a different section of the memory, a different segment of the memory, and then you want to raise an interrupt, and so on and so on and so on. So you set the flow, a predefined action flow. You can test it on the wizard, run the flow and see how it goes, and that everything is moving to the right places and all the parts are moving correctly. And then you simply generate the code and you can see the predefined actions in the code itself, okay, generated automatically. You can also, afterwards, you run and distribute it, and you can access the predefined actions from the user app. Let's see how it looks like. So here we have a memory and registers. One checks the status. Let's say one starts the DMA and one clears the DMA. This is the access registers, okay, in the memory. Then you can create predefined actions. You give it a name, and then you will have, let's say, demo 1, 2, 3. Then you can add the flows. Okay, you create flows with different steps. Check the status, start DMA, clear DMA, and check status again. Everything in order. Choose to read or write the data for the access register you created on the memory, on the bars. You can run the flow, test it there, and then you can generate the code. And once you've generated the code, you can see that you have the access registers, clear DMA, start DMA, and check status, and the flows, okay? Predefined action flow, read from the check status register, write everything just from here to here with all the functionality included with the WinDriver's code. As you can see, high-level API. And you can also run these flows from your user app. So it's a huge step towards no code. If WinDriver goal is to make developers' life much easier, what is easier than no code at all? So we're not yet there, but it's a big step towards a no code driver development solution. And I really really recommend first to try it yourself and see the webinar, the predefined actions webinar. If you want a link for this webinar, send me an email and I will send it to you. In the webinar, we demonstrate on cards. We show examples of how it works on an Edu card, educational card, how easy it is to perform complex operations using and set them from the UI, from the GUI, and then it works. Okay, so let's have a live overview, a quick look on on the wizard on WinDriver. Okay, that's really small. We start with this screen. One moment. Okay, so let's start a new project and choose our device. Here we have a Duagon device. Here you can see all the devices that are connected to your computer. You can also search for the specific device. If you can't find your device here, we recommend checking it on the device manager. So if your operating system does not recognize the device, there is probably an issue with the device itself or the connection to the operating system, because WinDriver reads it from the operating system. INF, as I said, I won't talk about it too much, but you can give it a name. Here you generate the device INF. WinDriver's kernel module INF is already installed. You can pre-allocate device to host DMA buffers and the host to device DMA buffers. What does that mean? In order to perform DMA, you need space, right? You need memory. If you have, let's say, if you assume or you have a suspicion that you won't have enough space to reserve for DMA after the boot, you can pre-allocate, okay, the device to host DMA and the host to device DMA. You can set the buffer here, and it will reserve the memory prior to the boot. But this is only for cases of very large memory segments that are required for the DMA. You have the option to support MSI interrupts, to automatically install the INF, which I will not choose because it is already installed. You can automatically generate and test sign catalog for the device INF. As I said, this is another feature from the latest version that allows you to install unsigned INF on your computer. And then it spares you the need to restart the computer and disable the digital signature enforcement by Windows. And this is a support for all the Windows 10 versions. Just a second. Okay, sorry, let's continue. Let's give it a name, intro webinar. Oh, what happened? I'm not sure. Let's see. Okay, that's weird. Let's open another device. Okay. So here we have the configuration space. This was set by the manufacturer. You can see the offsets, the access mode, the description, the details. You can start listening to interrupts on this device because it has interrupts. And you can see the memory. You can see the range of the memory, the bars, and you can add access registers, read and write memory, and also import registers. If you already have the description of the registers, you can import them. This is where you create the predefined actions. The only thing you need to do is give it a name, PDA, let's say 1, and add a predefined action. And then you will have a menu open for adding transfer commands and run the flow of the PDA. Another thing we can do here is see the licensing information. Use the WD-reg, which is, I will talk about it later. Utilize the debug monitor. Okay, so every kernel operation I'm doing is reflected in the debug monitor. Let's start listening to interrupts. Okay, again, I'm sorry, but the demo device suddenly is not working. But as you can see, I have the operations, the WDC int enable for starting listening to interrupts, and I see the error in red, and if this operation was successful, it would be green. Okay, so this is a great debugging tool, the WD debug, allowing to monitor the kernel operations. Let's generate a code. This window is maybe small, but it has a lot of, let's say, potential. Here you can choose the device-specific customization. Remember when I talked about samples for specific chipsets and manufacturers? So here we have the Altera QSys design, Avalon, Xilinx, QDMA, XDMA. As I said, it may not work on your device immediately. You may need to modify and change things, but it gives, let's say, a very thick hint for how to perform these operations successfully. You can choose the language. Okay, this sample comes only in C, but if I'm not customizing, you can choose Java, Python, C, .NET. Okay, and then we need to choose the IDE, the target development environment. We can choose CMake. You know what? Because we're going to build, let's choose Visual Studio. I'm not sure if it's 2022. Okay, so two things here. One, kernel plugin. Remember when we talked about the chunks of code sitting in the kernel mode, you can generate it from here, and you can generate a DLL. What does that mean? This is a dynamic library that takes only the logic, meaning it will not generate the user app, the GUI, let's say the GUI or the UI part of the user app, but it will generate a dynamic library containing the logic of your driver where you can implement it on other user apps. We will not use this one. Okay, we have a directory with our project's name. Let's open it. Close WinDriver in order to avoid resource overlap. We will get back to it. You see all the kernel operations I've done. Sorry for the small text. All the kernel operations I've done are monitored, and I can see the addresses. I can see the addresses, I can see the operations, everything that works well is in green, every error is in red. Let's go back to our intro web folder. These are these are code files, okay, in C. Let's open the solution. Okay, and as you can see, we have all the relevant files here. Okay, we have the diagnostic library here, all the required information. Let's get closer. Highly documented. We can see the diagnostic app. Okay, everything, the configurations, the registers that were set. The lib.c, which is the most critical file because this is the library. And let's build it. I haven't modified anything. Let's build the solution. Okay, so here we have the diagnostic app. Sorry again for the text size. Here I'm able to open it. Here we can see the vendor ID, the device ID, the location, interrupt options, the memory range, and then we can perform operations. If we will open the debugger, okay, again, you can see that the INF for this device is missing because we haven't installed one. But most of the other operations went well. The KP open driver failed because we don't have a kernel plugin that it was looking for. But you see every kernel operation was logged here. And if you have issues with your device or memory access, you can debug it there. Now we can read and write to the PCI configuration space, allocate or free shared buffer. Let's try to allocate the memory for the DMA. I'm not sure it will work because we don't have the INF installed, but let's try to allocate. Yeah, it worked. Great. So we've allocated 4,000 bytes to perform DMA. We chose the scatter gather, which means it's not a contiguous or one segment of memory to be allocated to the DMA, but a few memory segments. This is not a large size. 4,000 bytes, and we can see that we have 96 bytes allocated in this address, and 3,904 bytes in this physical address. Then you can take these addresses and perform the DMA, modify it on your code, call it, but this is done automatically by the user app and the WinDriver functions. Okay, so what I recommend, I've freed the DMA memory. What I recommend to you guys is to create a user app and start playing with it and see how easy it is. You see the predefined action flows we set on the wizard. Before that, PDA1, we didn't added predefined actions, but you can access it from here and run the flow from here. Okay, so we see that works as well. This was really easy, and you can do it by yourself and check your device. Test it. Another thing I want to do is to generate a code on Python. Okay, let's try to open the device now. Let's call it Python 1. No, okay, it doesn't want to work. I'll check that later. Let's take this one. Call it Python 2. Okay, this is a different card. I can see again the configuration space as well. Going to generate code, choose Python. No need to choose IDE because we're not going to compile anything. Here we have the kernel plugin option. Let's open the directory, close it. And one of the best things here with Python is that I don't need to do anything. Okay. I simply open the user app. I don't need to compile anything. I can do everything I've done with the C sample without compiling. So this is another thing I recommend checking and testing because again, the ease of use can be astonishing. Let's go back to the presentation. Just a second. Okay. Sorry for that. Let's continue. Let's talk about utilities. Okay, a few utilities before we're wrapping it up. So the first utility, and I think the most helpful one, is the debugger. We saw how you can access it. Actually, there is a util folder. I will show it to you right away. It's on WinDriver util folder. Here you have different utilities, PCI diag. We'll talk about everything on the presentation, but you have the debugger. You can set the driver name, the kernel module name, which it will monitor. You can choose the section, the status, the level, and you can also send the message to the operating system kernel debugger. If you're working on Linux, it's the WD message. And on Windows, it's WinDBG. And you can see what went wrong with your device, why things are not working. You can see the addresses, and you can send the log to us, and we can figure it out together. If you ever reached the support, we've probably asked you for these logs. Another great tool is the WD-reg. I showed you before. What is WD-reg? So as I said, WinDriver works with the kernel module. You cannot access the hardware without a valid and signed kernel module. By the way, it's the same on Linux. You must have a kernel module, command ls mode, to see the current modules that are running in order to access the kernel on Linux. So instead of starting working with different command lines and maybe make mistakes, we developed a WDirect front-end tool where you can install kernel modules, uninstall them, start them, stop them. And from version 16.2, you can also get into test sign mode and create test certificate. I won't dive into test certificate and test sign mode because it is very long and it's not relevant for Linux. But if you want, we have a dedicated webinar only for this. I can send you the link if you wish. So we have the WDirect tool. We have it on GUI, and you can also use it in CLI. And you can read more about it on chapter 16 on our documentation. Okay, the samples. A very important section, especially if you're not familiar with WinDriver. We have a variety of samples, sample code. You can access and get for inspiration purposes, but not just. Okay, so if we go to the sample folder, let's see, and let's say we'll go to Xilinx, you can see that we have an XDMA sample code. Okay, so if we click it, just a second. Okay, we can see that we have the implementation of a sample library accessing Xilinx PCI Express card with XDMA design using WinDriver WDC API. This is a complete code, DMA code. Again, highly elaborated, documented, with the different functions implementation, and you can see the architecture here, and anything you can do, okay, in order to perform DMA with your device. You don't need to start from scratch. If you want to create a DMA driver, this is the place for you, okay? You can see the different functions and how it works. And this is just one sample. We have an XDMA, QDMA. If we go for clients who ask about interrupt handler, I recommend go to the PCI diag, okay? And in the PCI lib, sorry, PCI diag. The diag is the diagnostic app. We need the PCI lib. You can see the library. We have a complete interrupt handler, okay? To see how it works, what are the functions that needs to be used, how to open and close a device. You can see the things you need to change in order for it to work properly with your device. If it's not working, transfer commands in case of interrupt raised. Again, very elaborate and highly documented. So the sample folder is a treasure. I recommend exploring it if you haven't done so already. Let's talk about the PCI and USB diag. Basically, these are complete interrupt handler source code that uses the WinDriver interrupt functions. We saw that, okay? It is a working sample. I think this is the most accurate, or let's say precise functionality. It is working. You can scan PCI cards or USB, and you can find them among a list. Why do we need it? Okay, and why it is considered a utility and not a sample? Because if your application is not working, you are not able to accessing your device with your application, or you're unable to to create a working application, simply open the PCI diag or the USB diag, diag for diagnostics. It works, okay? It works, and then you can find what went wrong when. Is it a build issue? Is it a device issue? If you are unable to open your device with the PCI diag, it is probably an issue with the operating system or the device itself. If it works with the PCI diag, then something is wrong with the user app or something else. But it is a great debugging tool because it's a working sample, okay, where you can access your device. You can also see it in the debugger, WD debug, the tool we mentioned before, and see what went wrong where. And it also has a kernel plugging sample. Okay. Let's talk about the licenses. We're getting to the end of the webinar. So basically, there are 3 types of licenses: the development license. Our licenses are bound to a particular computer registration code. So you have the development license to be activated on the computer you are developing on. Okay, so this is a development license. The development license is limited. It has an expiry date, okay, that is bound to the date you bought the license, 1 year, and it is not working with other apps, and it is running only on the development computer. If you want to distribute your driver, you have a distribution license. It is not working on the wizard. You cannot activate the distribution license on the wizard. However, it is working on other computers. It is working with different apps, and it does not have an expiry date. Okay, so let's say once you've ended your relationship with the WinDriver, the driver will not stop functioning. The distribution license does not have an expiry date. In order not to malfunction already distributed devices. And we have an SDK. We have an SDK license, which I don't need to explain. If you have more questions about the license type, please contact us, and I will make sure one of the account managers will talk to you. Let's talk about the special APIs. Again, not a lot of people are aware of the other APIs that we offer. IPC is an inter-process communication. Okay, this is IPC, inter-process communication API. It enables processes to communicate with each other and exchange data, regardless of whether they are running on the same computer. Okay, so basically what IPC is you can have 2 processes not running on the same computer, communicating with one another, and they have a shared interrupt handler. Okay, so they can send interrupt to one another. There is the shared kernel buffer API for allocating a shared buffer for different processes on the same computer. The SRIOV API supported on Linux only currently. It's a single root I/O virtualization, meaning an extended PCI capability, which makes one physical device appear as multiple virtual devices. Okay, virtualizing your device on your computer, SRIOV. The shared buffer APIs allows multiple devices drivers to share a single DMA buffer in a system. And of course, the server API for scanning more than 100 devices in a single computer. These are the special APIs. If you have a question on them, you can read on our documentation or contact me for further information. We also offer digital signature services for your drivers. As I said, if you want to distribute on Windows, to distribute your driver, you would need to sign it. Otherwise, your client or your user will experience an authorization issue. We offer digital signature services, including attestation signature, a signature verified by Microsoft. And other services that are not related to the product is one-on-ones and technical sessions. If you encounter issues or you want to talk or provide a feedback on WinDriver, please reach me out, and I would love to schedule a meeting. Whether it's a general, let's say more an overview or a review on WinDriver, or a technical session regarding a particular issue that you're struggling with, and we will debug and work it through together. Join our LinkedIn page. I don't know how did you got familiar with this webinar? How did you know about it? But we have a very active LinkedIn page. All the events are there. Also on the media and events section on our website. Join us on the future webinars. Stay updated. And thank you very much for everyone who attended. Here you see you have my email and our sales email. For any question, follow-up, or feedback, feel free to reach out. Thanks, everyone.